So now we have ERS 8804. It is a node that we set up with shortest path bridging. We establish adjacencies into the existing Fabric Connect network, and we've set up configuration fault management. In the previous videos, we've demonstrated that, and using CFM, we've shown the potential data forwarding paths that had moved over the network infrastructure. Now, I was going to move into IP shortcuts next, but I thought it smart at this point to take a visit to the link state database. The reason being is that ERS 8804 is, at this point, a skeleton. It has valid connectivity to the rest of the SPBM domain, but it as itself has no additional services provisioned. So I think it's important to visit what it's seeing at this point in time. Now, the type length values used for SPB are relatively straightforward. They're shown on this one single slide, and I do want to note that this will change over time. There will be additional TLVs that will be specified for IPv6, for instance, and for future certain functionalities that R&D is still working on. However, as you can see, the list is fairly short. And unlike MPLS, which is a traditional non-integrated overlay model of different protocol suites for different functionalities, these are integrated instances in a singular link state database that each and every SPB node within the domain possesses. This link state database gives Dijkstra knowledge to each and every service point of access within the network and the potential Ethernet switch paths to gain access and pathing through the network. We have three different colors we use to show the different TLVs. The gray shows the pre-existing TLVs, i.e. things like the area address, the end system neighbors, the protocol, all of which we looked at in previous videos. The one we have not looked at yet, and we will cover next, is called IP reachability, or TLV 135. This gives the ability for IP reachability or IP shortcuts across SPB. That will be the course and subject of the next video. However, in this video, we're focused on the type length values and the link state database. What does it look like? And give us a little step through, and we'll take a tour at this point. In addition to those gray TLVs, we see that there are the IEEE standards, those defined within IEEE 802.1AQ, which are TLVs 143 and 144 respectively. Those hold the SPBM instances BBIDs and also additional information in 144 such as the nickname, the BB lands, and also associated ISIDs, which are held in subcontext TLV 3. So, with that, we have the addition of a set of blue TLVs, which provide for the enhanced SPB capabilities of Avayas Fabric Connect. And those are IETF extensions, and you will see further extensions being posted for such things as IPv6. TLV 184 shows IPVPN reachability. TLV 185 and 186 provide for IP multicast type length value extensions. So all of this, once we learn how to read, becomes a very valuable visible window into the SPB network environment. So right now what we're going to do is we're just going to run the show ISIS LSDB detail. We're not going to do anything else in the course of this video. We're just going to take a tour. So at this point, the first node that we see is ERS 8801. As we know from our previous videos, this is a backbone core bridge. It really doesn't have much established with it. And as we can see as we move down through it, it tells us exactly what its neighbors are. So it tells us its reachability, and as we can see, ERS 8802 and ERS 8804 are reachable through it. We can also see that it has IP reachability in itself, and this is the ISIS address of the router node itself, and we'll talk about that when we actually go to configure IP shortcuts. But as we can see, there are really no other services established with this particular node. Now as we move on to ERS 8802, we're looking at a BEB. Here we can see that all of the lower level values are the same. Let's take note of TLV22, which gives us extended reachability, and we can see that adjacencies through 3 and 1 are there, just as the previous CFM diagnostics indicated. Now, as we move down through, we can see that we do have a populated TLV135, i.e., ERS 8802 does has IP services through IP shortcuts provisioned. As we can look further through TLV144, and let's just hit more again, and we'll come up and see that we indeed do have ISIDs configured through TLV144 sub TLV3. And we can see that we have two ISIDs, 1000 and 2001. We can see that 2001 indicates that it has a both transmit and receive path on the primary BV-LAN, whereas on the secondary BV-LAN, it only has a receive. The reason for this is the primary BV-LAN is its primary forwarding path. The reason for the receive allow on the secondary is to allow for SMLT dual homing at the resilient edge. And as we can see, 1000, due to the fact that it is an even ISID number, is converse in the fact that it uses the secondary BVID as its primary and allows transmit or receive back from SMLT dual home reserved edge through BVLAN ID 3998. And basically, as you can see, this is how we're able to provide load sharing for L2 PSNs. If we look up a little bit further at the TLVs, we can see that these IP subnets are reachable as well. And as we show IP routing later on in the next video, we'll show that we use the BVIDs equally in that context as well. Let's look a little bit further, and we're actually moving on to the secondary backbone core bridge, which is ERS 8803. And as we can see, it again is formed with a skeleton link state database that really doesn't have a lot of other information other than its extended reachability in neighbors and perhaps some IP information for its IS source node. And then finally, here's ourselves. This is our own instance, the one we've just configured. And as we can see, we have our own instances of our neighbors, and we can read that very clearly topologically, and the ability for us to validate that by a CFM is very key. There is the nickname that we just configured, giving us our shortest path ID. And as you can see, beyond that, we have nothing else configured. So that's just a real quick tour of the ISIS link state database in a skeleton context for ERS node 8804.